Hey everyone, we're going to do a couple of videos today on section 5.4, absolute maxima and minima. And just so you know, it's going to be a series of multiple videos. I've been having trouble doing longer ones, so I have to kind of keep each video to about 10 minutes or less. So I'm going to do the best I can. We will have pauses, but you'll notice that I already have a bunch of stuff written on the board, so you can pause the video and write all that down when it's appropriate. Okay, so remember that we were finding relative maxima and minima, and we were looking for peaks and valleys that were in a very small vicinity. And so we weren't really finding what we might consider the absolute. When we find the absolute maxima and minima, we are interested in finding the highest or lowest point on a graph. And you'll see I have several graphs here because sometimes we'll have an absolute maximum or a minimum. Sometimes we'll have multiple absolute maxima or minima. Sometimes we won't have either. So you can see on this first graph on the left, and who cares what the graph really looks like in total, we know that it is increasing, or it's going towards positive infinity on the left and the right. So we have an absolute minimum down here at the very bottom of the curve. The next graph over is just a linear graph, and you can see that it has neither an absolute maximum or minimum. So we're trying to find actual values. Infinity or negative infinity won't be actual values. So if that's the case, we just don't have a maximum or minimum. In this kind of crazy graph, we actually have both. We have absolute minimums here and here because we can see the left and right hand behavior of the graph is going towards 0. And we also have an absolute maximum up here at the top. The next graph over is kind of interesting because now we're talking about finding an absolute maximum or minimum on what we call an open interval, so between A and B. And you can see, since this is going to positive infinity and on the right it's going to negative infinity, that we do not have an absolute max or min. And then the last one down here, we actually have what we consider a closed interval. I'm going to try to make that a little bit closer for you guys so you can see it. So we've got both an absolute max and absolute minimum. So now we're saying between A and B, but including A and B, what's happening. And even though that's a linear function, we can see that we can find an actual maximum and an actual minimum there. Okay, so I'll move this back. All right, so we have a couple of theorems that we need to talk about regarding absolute maxima and minima. So let me get erased quickly so we can talk about those theorems. The first one is called the extreme value theorem. So remember, most of our theorems don't always have names. This one does. Called the extreme value theorem. And the extreme value theorem says if a function f is continuous on a finite closed interval. Finite, of course, meaning that we can count it. It's able to be, we know the beginning and we know the end. So it'll look like this. It'll be kind of like that last graph we just looked at, A to B, including A and B. Then F has both an absolute maximum and an absolute minimum on the interval A to B. Okay. We have another theorem. This one does not have a name, so it's just kind of an interesting one. It says if f has an absolute here's an interesting word, extremum on an open interval. So this time it's an open interval, different than the last one, which was a closed interval. A to B. So now we're not including A and B, but everything just up to A and everything just up to B, which is why it's considered open, because we can't really know for sure what is the last number right before we're exactly equal to A. Then it must occur at a critical point of F. Okay. All right, I just realized that I think my head was getting in there. You're seeing my nighttime hairdo, so sorry about that. It is what it is, all right? Okay, we're going to move on. Okay, so we're going to use these couple of theorems to help us find some absolute maxima and absolute minima. So let's erase this again if you need to. Pause it and get it written down. Not and. To find the absolute extrema of a continuous function f on a finite closed interval A to B. We really just have three little things that we have to do. First, we're going to find the critical points of F. Now, this is something we have been doing. Find the critical points of F in A to B. So remember, to find those critical points, what we're talking about are turning points of the graph. So this is where we find the derivative, set the derivative equal to 0, and find those x values where we might have turning points, which again is where we might find absolute max or mins on an interval. Okay. Second, we're going to evaluate f. At all the critical points and at the endpoints. A and B. And then the last thing is the largest value in step 2 is the absolute maximum on the interval A to B, and the smallest value is the absolute minimum. Okay. All right, we're going to pause there, and I'll come back with another video in a minute with a couple of examples.